This is Rahul from Hyderabad. This video is for the final assignment of foundation design by Sky Labs. Here the question is we have to design a mat foundation for the tall building which we have designed in the ETABS course. And here we firstly we input the column dimensions, dead load, kilonewton, and materials used for each and every column from the ETAB software. And here then and after that we calculate the subgrade modulus, which is equal to the SBC divided by allowable settlement, and it gives 3 into 10 to the power 4 kilonewton per meter cube. Design step, which is equal to 0.25 times of L1 or 0.25 times of L2, whichever is less. Here a design strip column design strip length is 4.5 meters, but we consider it to be 4 meters, and the footing dimensions are 22 meters by 22 meters, as you can see. And now first we open a new model. We give the design preferences, which is the covers for the footing, which is 50 mm at the top and 50 mm at the bottom. And then we give a preferable rebar size, which is 22 here. And then we move forward and we choose a grid only option, where we give the number of guidelines in x direction, which is 19, and in y direction also it is 19, and spacing is 1 meter on each of the axes. And then we once once we are done with the grid settings, we click on OK, and a grid is formed. And then we define the materials, which is M40 and HYSD 500, and we give the appropriate properties like the unit weight, the characteristic compressive strength, yield strength, etc. And then we give the slab property, where we define the mat property for a thickness of 1200 mm. And here you can see the slab property, the slab one. Here it's M40 and the thickness is 1200 mm. And then once we have defined the slab property, we define the column properties. Here there are only two types of columns in the whole structure, so we define two column properties, and then draw the columns. Then once we have defined the column property, we define the solid subgrade property. As you can see, we defined the soil one, where we give the soil modulus, so subgrade modulus of the soil, which is 3 into 10 to the power 4. And then we draw next once we have and then we define the load combinations, and for ultimate and the service load and the service cases. And after we have defined all the properties, we draw the slab area we draw the slab area using the draw option, using the draw and draw slab areas, choose the appropriate property and draw on the grid lines. And once we have drawn the area, we have we have we have used edit option, and then edit areas, and there we have expanded the footing slab for 2 meters on each side. And thus the footing is drawn. After the footing is drawn, we draw the columns using the draw column, select the appropriate property and make the settings, and we draw each of the columns carefully. And after we have drawn the columns, we draw the design strips. Here draw design strips, and we draw strip layers A, that is in horizontal direction, and strip layers B, which is on the vertical direction, 4 meters, which is 4 meters on either side of the column. And then we need to assign the footing. We need to assign the support data. That is, here we go to assign. First we select the column. So first we select the footing, and then we go to assign soil data, support data, soil properties, and we assign the property which we have defined earlier, which is soil 1. And then we click on the center point of we click on the center point of the column, and then we go to assign. Here we give load data, point loads. Here we enter the dead load and live load and the dimension of the column. Here we do it for each and every column. And once we have given the column loads, that is live load and dead load, we we sa- we give the uh, we change the rebar material for the slab for the design strips as well. And once we have drawn the design strips, we run analysis. Once the analysis is done, we can see the deflections, which is in mm, which shows only for dead load. We can change the load here, display, show deform shape, and here we can select respective loads, respective combination, and we can even see the color code given, and we can take the deflection. And uh, and after the analysis is done, we run analysis and design. After the analysis is done, the model is locked, the model is freezed. We cannot make any changes. And here, once the design is complete, we go to display, show punching shear design. These are the punching shears ratio, which means it is a ratio of the load coming, and the shear load and the shear resistance the column can in, which means it has to be less than 1 for the column to satisfy the design check. And as all the ratios are less than 1, our footing is safe, and it can be used practically, and it can be constructed. And we can view we run detailing, and after the detailing is run, we can see the slab views, individual slab. If we expand this mat, we can see the rebar plan here. Like, this is the top rebar plan, this is the bottom rebar plan, this is the reinforcement profile of it, which gives the reinforcement intensities. And then after that, we can see the bill of quantities here, rebar schedule, and here show slab. Here we can view the slab force stresses. You can see here M max, we choose dead load and apply. Here you can hover the cursor over and check for the maximum moment. And then display show slab design. Here we impose minimum reinforcement and apply, which shows the reinforcement intensities over strip A. Select layer B, and we can hover the cursor over the layer B's, and we can check the reinforcement intensities. Likewise, we can also see the deform shape. We can see the slab forces. We can see the strip forces. We can see the slab design, etc. Here we can view all the reinforcement types, that is for the layer A, layer B, and section profiles, and bottom rebar plan. This is all bars. This is Then we can see the drawing. Then we can see the bill of quantities, the rebar schedule, rebar table. There are many more options to uh, there are many more options in the detailing tab. And as you can see, thank you.